Okay, as I said for the stats class, I was going to go over this question. We went over it in class. We're going to go over it again. It says, according to government data, 22% of American children under the age of 6 live in households with income less than the official poverty level. A study of learning in early childhood chooses an SRS of 300 kids. What is the probability that more than 20% of the sample are from poverty households? Okay, so again, it's a sample proportion question. And what do we know about the problem? We know that P is going to equal 0.22. We take an SRS of 300 kids, which means N is 300. And what we're looking for is looking for the probability that P hat is going to be greater than or equal to 0.20. Okay, so what do we know about this probability before we go any further? If it's more than, this is the same as 1 minus the probability that P hat is going to be less than 0.20. So that's where we're trying to get to. All right, so before we can get going with a sample proportion problem, we need to check our conditions. There are 3 conditions we need to check. Condition number 1 is the sample must be an SRS, and that is stated in the problem. Okay, one of the reasons why we want it to be an SRS is because then we can say we know or assume that what we know about the population and the sample are going to be the same. Number 2, what we have to do is we have to know that our population is at least 10 times our sample. All right, and what do we have? We have 300 children, and our data represents of all American children, so we're good. All American children is going to be at least 10 times 300, and this allows us to use our standard deviation formula of P times 1 minus P over N. All right, and we're going to check that out in a second. And then number 3, our third test is we have to make sure that N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. And if we go, we have our N, which is 300, and we're going to multiply that by my P, which is 0.22, and that's going to equal, go to my calculator, I have 300 times 0.22, and we're going to get 66, which is greater than 10, and then we're going to get 300 times 0.78, which we should realize that, that's definitely going to be greater than 10^234 is greater than or equal to 10. So we're good. And then this allows us to assume that things are normal. So if that's true, for the distribution for this problem then is going to be normal. We're going to assume that the mean is going to be the same as the mean for the population, which is going to be 0.22. And our standard deviation we are going to now figure out here, which is going to be our P number, our square root of our P number, which is 0.22, times 1 minus P, which is 0.78, divided by 300. When we do that, we get 0.22 times 0.78, and then we're going to divide that by 300, and then that's the number I want to take the square root of, and we're going to wind up with 0.0239. 0.0239 as a standard deviation for this problem. Okay, so now we're kind of ready to go. So we have our conditions met. We come back up to our probability statement, which is this. And what we're going to try to do is we're going to try to standardize this score of 0.20 knowing this. So we're going to come up with a z-score for 0.20. So it's going to be 0.20 minus 0.22 divided by 0.0239. That's going to get me a negative 0.02 over 0.0239. When we divide that, again, calculator, negative 0.02 divided by 0.0239, and we're going to get a negative 0.84. Negative 0.84. Now that's a z-score. So now we're going to change our problem we change our problem to 1 minus the probability 1 minus the probability that z is going to be equal to 0.84, negative 0.84. Well, that's going to be 1 minus, and then we go to our z table. Give me a second to get there. We go to our z table, and we're going to go down. I don't know if you can see it, but we're going to go down to 0.8, negative 0.8, and all the way over to 4, which is here, 2005. So 0.2005. Get all set up again. 0.2005, and then that's going to equal, we get 0.7995 as a final answer. So the probability, if it's true that 22% of all American children under the age of 6 live in households with incomes less than the official poverty level, if we select 300 children from that population, the probability that we get a percent that's more than 20% of that sample who live in a poverty level, the probability of us getting a sample with more than 20% is 79.95. Pretty good chance.